In this video, we're going to study how to factor polynomials. So a polynomial is something which has the form. So you can say polynomials have the form. Polynomials have the form. Polynomials have the form a, which is a number axn plus bxn minus 1. So the power reduced by 1 like that, and then at the end it's going to be a number x plus it should be cx plus d. So this is the format of a polynomial, and we assume that these numbers are integers. So that's the assumption. So assume that uh, the numbers are integers. Numbers a, b, c like that are integers. Okay, so we can talk about these four techniques. So the methods discussed. So we can talk about these four. We discussed four methods. The first one is removing common factors. The second one is special forms. So there are three forms: the difference of squares, perfect squares, and sum and difference of cubes. And then factoring trinomials, the polynomials with three terms. And then also we talk about the grouping method. That's very important when you have more than three terms. So let's start with the first one. Factoring by removing common factors. So in this method, what we're going to do is we're going to remove the common factor. So let's say, so factor out the largest, factor out the largest common numbers, in this case, common numbers and common variables, variables. So it will be clear from an example. So let's look at a few examples. So let's say we have as the first one 2x minus 3x squared. So when you look at this problem, you can see that there is no common numbers to these two. There are no common factors. We have 2 and 3. So there's no common factor, but you can see that x is common to these two. So what we're going to do, so we can pull out x from both. So if we pull out x from both, so what we can rewrite is, this is just exaggeration how things going to work. So we can write this one as x times 2, the first term, and the next term we can write as x times negative 3x. So we just separate the x term. Now what we can do is we can take that term out. So we're going to pull out that term. So from the first one, you're going to get x. Next term, after you pull out x, you're going to get negative 3x. So that's what's happened. But you can directly write this answer. But I just show you like what's going on here. So let's look at the next one. So how about 6x cube minus 4x? So when you look at this one, you can see that there are common numbers now. So if you look at 6 and 4, the common number would be 2. So that means that's a common number, and also you can see that you can pull out x term from these two. That means 2x is common. So again, as before, we can say 2x, you pull out 2x. So from the first one, you're going to get 3x squared. Those are the other terms that we have. And the next one is, again, you can pull out 2x. So when you pull out 2x, you're going to get negative 4. Actually negative 2, because we have negative 4, so negative 2. And there are no extra x terms because we pull out the x term. Now what we can do, we can write this one as, so you pull out 2x, and then you have left 3x squared from the first one, negative 2 from the second one. So that is 3x squared, and the negative 2 from the second one. So that is how you're going to factor that. So let's look at a few more examples. So as the next one, let's say you have a negative 4x squared plus 12x cubed. So when you look at these, you can see that negative 4, or you can say 4, is a common factor to those two. So you can pull out negative 4. That's the number you can pull out, largest number you can pull out, negative 4. And in terms of variable, you can see that one has x squared, the other one has x cubed. So you can say x, you can pull out x squared. So that is the common term that you can pull out. So once you do that, from the first one, you're gonna get 1 as a factor left here. And again, from the next one, if you pull out negative 4x squared, and you can see that to get 12, you get negative 3 left here. And then also there's only 1x left. So now we can write the common factor, which is negative 4x squared in both. This is extra step that this is like optional extra step. You don't need that. And then from the first one, you get 1. From the second one, you get negative 3x. That's the way you can factor this. And then part D, so you can do that negative 4x squared plus 12x minus 16. Again, if you look at the common factors, you can see that negative 4 is a common factor. So once you, so pulling out a number means you divide everything by negative. That's another way to you divide everything by negative 4. That's another way to look at these kind of things. So let's do that to see how we can use that idea. So that means negative 4x squared. You're pulling out negative 4 means you divide everything by negative 4. And then the next term is 12x. You divide by negative 4. And then we have a negative 16. Yeah, you can write this one as negative 16. So you have and then divided by negative 4. So this is like another step to see how those things gonna happen. And then it's negative 4, and you can see negative 4 means it is 1, so that means you get x squared. In the next one, you can see that we have 12 and negative 4. When you divide, you get negative 3x, and then the next one is negative get cancelled, and then you will get 16 over 4, so which is 4. So that's how you can see that. And then what's going to happen is now, since this is quadratic, you can still factor this. So what we can do, if possible, we need to factor this again. So need to factor. So that's what we are trying to do, but that we can discuss later. So right now we can stop in these intermediate steps. So let's do one last one. So let's say E. How about this one? X minus 2 times 3x, and then minus x minus 2 times 2. So if you look at this problem, and you can see that x minus 2 is a common factor already. So we're gonna pull that out. Once you pull that out, you can see from the first one, you left with 3x. That's that term. And from the next one, you also have a negative sign left, and then 2 left. So negative 2. So and then you can see that's the complete factorization of this one. Okay, so let's talk about the next type, the special forms. Under special forms, there are 3 types to discuss. So the first one, the difference of squares. So difference squares means when you have a squared minus b squared, we can factor this as a minus b and a plus b. So that is the formula that we're going to use. So this is a common form, and we're going to use this a lot. So we can probably see why this is true. So if you go backward, if you write a minus b, if you start with a minus b and a plus b, what we can do is we can distribute. So when you multiply, you're going to get a times a, which is a squared, and then you have a times b, so you're going to multiply a with b, so you're going to get plus ab. Now do the same thing with the other terms. So you're going to multiply minus a with a, so which is a minus ba, and then you're going to multiply minus b with b. So then you're going to get minus b squared. And you can see that ab and ba are the same in algebra. So that means those two terms get cancelled because there's a negative sign. So they're going to cancel out. So you simply end up getting a squared minus b squared. So that means we can write it backward. That's why we have this difference of squares formula. So the next type is perfect squares. So perfect squares have two forms. So the first one is if we have a squared plus 2 times ab plus b squared, we can write this one as a plus b, and then this means a plus b whole thing squared. So that's a perfect square. It works for any a or b. And there's a similar formula for the difference. If you have minus sign, that's only change. You can write this one as a minus b times a minus b. This is equal to a minus b whole thing squared. So that's the one for the minus sign. That means if it's a plus sign, you get a plus sign. If it is a minus sign, you get a minus sign. And then also you can see that in both there is there's a number 2 in both of them. Good. That's what we call the perfect squares. So let's look at the next one. Next we have sum and difference of cubes. So this have this special form. So it is a3 plus b3. So it's a sum of cubes. This is sum of cubes. The first term follow the exact same format. That means a plus sign. Then it's go with the plus sign. So that means a3 plus b3 equals to a plus b. And then there's a quadratic term. So it's going to be a squared. The opposite sign. So that means there's a plus sign. Go with a minus sign. And there's no 2 here. So it's going to be a squared minus ab. That's the other difference. And then b squared. That's always positive. So you notice few things. If it's a plus, go with a plus, and then there's a minus sign here. And then we have a similar term. It is a3 minus b3. This is also, now you can write, it's the same term. So a minus b. And then a square, the opposite sign. That means plus ab plus b square. These are what we call sum and difference of cubes. So let's look at several examples now. So let's focus on the first type. The first type is a factor using difference of squares. So factor using difference of squares. Difference of squares. So let's look at these problems. So let's say the first one is 4 minus 9x squared. So when you get something like that, and you can see that it doesn't look like a difference of squares formula. So what we're going to do, we're going to bring this to the form. So that means first we can write the 4 as 2 squared, and the 9x squared you can write as 3x whole thing squared. Now when you do that, you can see it looks like a squared minus b squared, and in this case you can see a equals 2 and the b equals 3x. So that means we can use the formula. So that means first term has the form a minus b. So that means 2 minus 3x. The second one has the form a plus b. That means 2 plus 3x. So that's how we're gonna do it. So that means the first term has a minus b form. The second one has a plus b form. Good. So the next one, let's say we have 3 minus 12y squared. So there are two problems here. The first problem is you don't see any squares here as number wise. So what we're going to do, we're going to pull the common factor out first. You can say you can pull 3 out. Once you take 3 out, you can write this one as 1 minus 4y squared. So that's the first step. And then after that, you can see you can write this one using square. So you can say 1 means 1 squared. 4y squared you can write as 2y whole thing squared. Now this is in the form a squared minus b squared. So we can write using the difference squares formula. It is 3. First term going to be 1 minus 2y. That is the a minus b term. Next one is a plus b. This is 1 plus 2y. So that's how you're going to factor, but how we start with? We start with pulling a common factor 3 out. So let's look at another one, C. So how about x plus 3 squared minus y squared? This is like very clear what is a and b. So a equal to x plus 3, b equal to y. So that means, so if you write it, it's very clear in this case. So this is just a minus b and a plus b. So we just need to plug in here. So that means a means x plus 3, so it's x plus 3 minus b means y, so that's the first term. The second term is x plus 3 plus y. So that's a very straightforward situation. Good. So let's do one more example. How about this one? D. So it is 32x to the fourth minus 162. Again, we can see few problems here. As last time, we don't see any other than x to the fourth. We don't see any complete square numbers. So again, we're gonna pull 2 out. Once you pull 2 out, you can see this is 16x to the fourth minus. If you pull 2 out, this is gonna be 81. And then you don't see squares, but you see fourth power. So that means fourth power means you can write this one as square of a square, because so this is what we notice, x to the fourth actually equals to x squared squared. So that's what we're going to use here. So that means you can we try to rewrite this one as, so you can say first you can write this one as 4x squared squared. That's the first term. The second term you can write as 9 squared. So that's the first thing you can do. First you write them as different squares. Now we can use the different squares formula. So we can write this on 2. First one going to be 4x squared minus 9. And then we have 4x squared plus 9. So we feel like we are done. Actually, we are not done yet, because this one you can rewrite again. The difference one you can rewrite. The other one you cannot. That's you stop there, because there's no negative sign here. So, but the one with the negative sign you can go forward. So what we can do is you can write 2. I'm going to move the 4x squared term here plus 9 term here, because we are done with that. The other one you can write as 2x squared, the first term, and the other one is 3 squared. Now we can use the different squares formula again for this one. So that means if you do that, it's a 2, you get 4x squared plus 9, and this one you can write as 2x minus 3 and then 2x plus 3. And you can see that since we cannot factor this one further, so this is the complete factorization of this one. That's an interesting problem. And then you can try these two problems as practice. So how about the first one? You're going to factor x minus 1 squared minus 9 y to the, let's say, fourth power. And part B, how about 100 minus 4x squared? Think about how to, we don't see, you see squares, but see whether there are like what ways you can do this. Okay, so let's go to the third method. It's actually the second method, so the perfect square. So so our formula is a squared plus 2ab plus b squared. Let's see how we can actually factor this. What I'm going to do, I'm going to split the middle term into 2 terms. So if you do that, so you can write this one as a squared plus ab and write another ab plus b squared. Now you can see why we do that, because this is 2ab. So now what we can do, I can find a common factor of this and another common factor of that. So if you look at the first one, you can see a is a common factor, so it's going to be a plus b. The next one, you can see b is a common factor, so it's a plus b again. Now, since this is a common factor, as we did in the very first examples, when you talk about taking common factors, you can see you can pull out a plus b. You take the common factor out. Once you take the common factor out, from the first one, you're going to get a. And from the second one, you're going to get b. So that's how you can write this one. Now you can see this is the exact same term. So you can write this one as a plus b whole thing squared. So this is one way to factor this. So same argument works with the other one, a squared minus 2ab plus b squared. So if you do the similar argument, you can see that you end up getting a minus b squared. So those are the identities. So let's see how we can use these identities. This is in several examples. So, example, say factor. So the first one is x squared minus 6x plus 9. So the goal is to figure out what is a and what is b. And then after you figure out a and b, and then we're going to see the squared term, and also we're going to see whether it's actually going to generate the middle term. So we're gonna check on this one. We're gonna check whether it's going to generate the middle term after figure out a and b. So let's do it here. So here you can see that it's x squared, so it's clearly a equal x, and then 9 means 3 squared. So we notice that. And then what we try to do, we try to see whether this can generate the middle term. In this case, the first example, actually what we have is a minus sign. So that means we're going to go with the minus term. So we're going to go with the minus term. So let's see whether we have the negative 2ab term. So that means a negative 2 times, what is a? A is x. And what is b? B is 3. And then this is always a plus sign. Now we check whether we have this term, and you can see that that's exactly what we have here. That means this is in the right format. Because this is in the right format, the factorization is simply a minus b squared. A means x minus b, that means 3 squared. So you can see this sign gonna match with that sign, because this is always positive. That doesn't give you the sign, so you have to be careful with this. Good. So that's the first example. So it's a minus, go with a minus sign. So let's look at the next example. How about this one? So let's say 9x squared plus 30x plus 25. So we do the similar argument here. We're going to figure out what is a. So you can see this one you can write as 3x squared. So a equal 3x. And then 25. 25 you can write as 5 squared. So, and then we try to generate the middle term. So it is plus 2 times a and b. And then you can see that this actually equals to 30x. So that means yes. So that's the right format. So that means the answer would be a plus b squared. So it's 3x plus 5 squared. You can write it like that. So that's the argument here. We check whether it is in the right format. If it's a minus, go with the minus sign, and it's a plus, go with the plus sign. So you can try these as practice problems. So you can try, let's say 16x squared minus 24x plus 9. How about this one? Can you do the same thing with x squared minus 24x 24x minus 9? And you can see that you cannot, because there's a negative sign there. That means it's not in this perfect squares form. So this is not of this form. So that means for these problems you can use this argument, because there's a negative sign here. Okay, so let's talk about the difference of sums and cubes. difference and sum of cubes. So we have the formula. So the formula is a3 minus b3 equal a minus b, and then a squared plus ab plus b squared. And then for the sum, we have a3 plus b3 equal a plus b, and then a squared minus ab plus b squared. So those are two formulas, and let's look at several examples. And then one thing you notice is that you can see that there is no 2 term here. So that's, you can remember. So there's no 2. So that's how we remember. Otherwise, this looks like perfect squares, but there's no 2 here. Good. So let's look at some examples. So the first one is x3 minus 8. So this one you can write as, so you need a cube, but you know that 8 is 2 to the cube. So we can write this one as x3 minus 2, 3. So then according to the formula, the first factor going to be x minus 2 because a equal x. So here what happened is a equal x and b equal 2. I mean, we can directly use the formula. So that means, and then x squared plus ab, that means 2x, and then b squared, which is 2 squared, which is 4. That's how we write the factorization. So as the next example, we can look at this one. So we have 5y3 plus 135. So you can see that these are not complete squares, so we can pull 5 out. If you pull 5 out, you can see y3 plus 27 here. But what we notice is 27 is 3 cube. So because of that, now we can use the cube formula for that one. So it's a 5. The first term going to be y plus 3. The second one going to be y squared minus 3y, because there's a minus sign, and the product. And then the square of the last one, which is 9. So that's how you can use the difference of the sum of cubes formula. But you have to factor 5 first. Good. So let's talk about the factoring of trinomial next. Factoring of trinomials. So trinomials are polynomials with 3 terms. So it is like ax squared plus bx plus c. So we try to see whether we can write this as a product of linear factors. So like for example, we see whether we can write this one as a number and then x plus another number. That's the first term going to look like. And then similarly, the other term is a number and then x and then plus another number. So what we notice is, what are these numbers? So the first, you can see that the first 2 numbers are, you can see this number and that number. The first 2 numbers are factors of a. So these are factors of a. And then the other 2 numbers, the constant terms, you can see these are factors of c. So that's how it's going to be. And then we see that we're going to check whether after we multiply through, after we distribute, do we get the middle term. That's how we're trying to do. So it's a kind of what we normally do is we can use a trial and error situation. We can think of factors of a, and then we can think of factors of c, and then multiply through and see whether we get the middle term. So so we can say use a trial and error. Use a trial and error kind of situation. So you can think of all kind of factors and multiply through. Trial and error method to get the middle term. To get the middle term. Bx. That's what we're trying to do. Actually, we because it can be like really complicated if a and b have many factors. For example, if a is like number 12, it has so many factors. If c equals 15 or 24, there are so many factors. Or 36 can be worse. So that means this can be like really time consuming. But there's a different method that I use here. So I'm going to call this so we can use my method. Um, Actually, I'm going to call this the magic factorization. Magic factorization. Because you can see that this can give you this, I just call this now name. This can give you the factorization directly. I mean, we don't want to like check anything major. So let's see how it's going to work. So let's look at a problem and then it will be clear from that example. So let's see how the magic factorization work. So let's look at this problem. So let's say we have 6x squared minus 13x minus 5. So let's say we're going to factor this problem, factor this polynomial. Now you notice that 6 has several factors, 6 times 1 and 2 times 3 and 2 times 3, 3 times 2, so we can write it like that. So how we do this, first we're going to look for what is the product these two are going to give. So that's like a standard way to do a problem like that. So when you multiply 6 and negative 5, and you can see that you're going to get negative 30. And then we do the standard way. So what we do, and then we're going to think of factors of 30 that's going to add up to negative 13. So what are the factors of 30 that is going to add up to negative 13? And you can see that because there are several factors, 30 times 1, 6 times 5, and 15 times 2, things like that. And you can see that those two factors that work are negative 15 and 2. Because you can see that when you add them, you end up getting negative 13. So that's the middle term, middle coefficient. So that works. So that's the first step to figure out what are those two terms is negative 15 and 2. And then what we're going to do, we're going to think of factors of the leading term, just the leading term. We're going to look for factors that's going to divide those two separately. For example, let's say you pick 6 and 1. 6 and 1. So you can see that 6 doesn't divide those two evenly. So that means this is not a good factorization. So what we can do, we're going to go with 3 and 2. 3 and 2. Why we do that? You can see 3 divides 15, 2 divides 2. So we are not going to go with 2 and 3. The reason is 2 do not divide 15 and 3 do not divide 2. So what we're going to do, we're going to pick the right factorization in the right order. That means these two are the numbers we are going to pick. So that means we first pick the two factors of negative 30. That's going to add up to the middle term. And then we think of factors of the leading term that's going to evenly divide those two terms. And after that, we can directly write the factorization now. This is how it's going to work. This is not in the books, so you need to look at this one. So what we write this term as a 3x, that's the first term. And then the other one we get is 2x. So we are looking for the constant term. This is how we get the constant terms, very simple. So to get the constant term on this side, what we're going to do, we can divide negative 15 by 3. Where 3 is the leading coefficient. That means it has to be negative 5. And do the same thing with the other one. To get this term, what we're going to do, we're going to divide 2. That was the other constant term. So we can divide 2 by 2 because 2 is the leading 2 is the coefficient of the second factor. So that means you're going to get plus 1. So that's how you can write the factorization directly, and you don't need to use a trial and error method, because if you trial and error, you have so many factors to consider. So yeah, let's do a few more examples to make sure that we understand this argument. So I'm going to call this the magic factorization because it's going to work really fast. Okay, let's do a few more examples. So the next one, we can look at 6x squared plus 17x plus 5. So again, we're going to look at the multiples of these two, which is 30. So 30. And then we're going to think of two factors of 30 that's going to add up to 17. And you can see that it is 15 and 2. So we find those two. That's the first step. We find the two factors of 30 that's going to add up to the middle coefficient with the sign. Next, what we're going to do, we're going to think of two numbers, two factors of 6 that's going to evenly divide these two numbers. And again, you can see that those two numbers are 3 and 2, because 3 divided 15, and then 2 divide 2. So that means we have the right factorization, so we can write the answer now. So it is, so we can write this 3x and then 2x. So again, this number goes here is 15 divided by 3. That's why I pick numbers like that. So that means it is going to be a plus 5. And do the same thing to get the other number. You divide 2 by 2. So we divide the two 2's. So one is this one, the other one is that one. That means the number goes here is plus 1. Good. So that's a factorization. So let's do just one more problem, because this is a kind of new idea. So 12x squared minus 7x minus 5. So again, we can look at the multiple of these two. So which is 12 times negative 5. So 12 times negative 5, which is negative 60. So think of two factors that's going to add up to negative 7. They're going to add up to negative 7. And then you can see that those factors are negative 12 and 5. Negative 12 and 5 add up to negative 7. So you get the middle term. That means we have the right factors. Now what we can do, we can think of factors of 12 that's evenly divide those two numbers. So you can see that, so let's look at several cases. For example, let's say we have 4 and 3 is a factorization, but the problem is none of them divide 5. That means this is not going to work. And even if you switch the order, not going to work. So that's the first one. And then what other factorizations we have? We have also 6 times 2. You can see that 2, so in this case, none of them directly divide 5. So that means it's not going to work. So that means this one also not going to work. That means you don't want to try any of them. So only option that works here is 12 times 1. Because 12 divides 12 and 1 divides 5. So that's the only one works, and we're going to proceed with this. So that means it saves a lot of time, because we don't want to try anything else. So we're going to go with that. So that means it's going to be 12 x and then x. So again, the number goes here is negative 12 divided by 12, so which is negative 1. And the other way, you can see it is just 5 divided by 1. So that means plus 5. You can see this works. Okay, so that's the factorization is direct, because if you just want to think of trial and error, it can take a lot of time, because there are a lot of factorization you need to consider. But in this case, like you can see, 12 has so many factors, so there are so many things to consider. So but in this argument, you don't have to do that. Okay, so you can try these and see whether you're going to get the answer quickly. So the first one is 2x squared plus x minus 15. And the second one is 12x squared plus 7x plus 1. That's an interesting story. The first one has 8 possibilities if you use a trial and error method. So has 8 possible factors. So you can see that the trial and error method is not going to be the best option for these kind of problems. But in this one, it's straightforward. You're going to get the answer right there. Okay, so that's about that. And then you can also see that if a equal 1, things are very easy, because if the leading coefficient is 1, you don't have to think about any other factors, because 1 has factor 1. That means you directly get the answer. You just need to find the factors of the product. That's it. So that's the easy case. So it's directly coming from this argument. So you can see when a equals 1, things are easy, because a, which is equal to 1, going to factor into 1 and 1. So that means we don't want to worry about that anymore. So for example, let's look at these two. So how about x squared minus 7x plus 12? So that means we just need to think of factors of 12. That's going to add up to negative 7. That means the factors are negative 4 and negative 3, because that's going to add up to negative 7. That means those are the answers directly. So that means it has to be x minus 4, x minus 3. The reason is because how we normally get this one using this magic factorization, how we get it, we just divide those numbers by 1. That means it's just the same number. So that's why you don't want to do that. So you get the answer directly. And then part B, how about this one? X squared minus x minus 6. Again, you just need to think of factors of negative 6. So that's going to add up to negative 1. So negative 6. The factors that's going to add up to negative 1 is negative 3 and 2. Because those two numbers can add up to negative 1. So that means the factorization is directly x minus 3, that's the first number, x plus 2, that's the second number. So those ones are very easy to do under this argument. Okay, so let's do the last topic, which is factoring by grouping. So factor by grouping. So factor by grouping we use when there are more than 3 terms. So use when there are more than 3 terms. More than 3 terms. So this is a kind of standard technique for more than 3 terms. So let's see how that's going to work through an example. So let's say factor. So let's look at x cubed minus 3x squared plus 4x minus 12. So if you get a term like that, what we can do, I'm going to rewrite this to show you the arguments, which is x3 minus 3x squared plus 4x minus 12. So we're going to group it. That's why we call grouping. We're going to group the first two and the next two like that. And then from each group, we try to find the largest common factor. We normally do it for the first one. So if you look at the first one, you can see that x squared is common in the first two. So if you pull x squared out, you're going to get x minus 3. Now the goal is to create this term in the next one. If you do not create this term, you can do this argument. So we try to create x minus 3. To create x minus 3, you're going to pull 4 out. So if you pull 4 out, you're going to get x minus 3. Now you can see that this term is common, so we can write that first. So x minus 3, and then you're going to get x squared from the first term, and then you're going to get plus 4 from the second term. So that's how it's going to work, and you can see that the second factor x squared plus 4 do not have more factors. That means this is the complete factorization. So let's look at one more example just to see how it works. This is a very simple argument. It's called grouping method. So you group 2 and 2 and then try to pull the common factor out. The next one. So let's say we're going to do x3 plus 2x squared minus 9x minus 18. So again, I'm going to rewrite this. This step is actually not really necessary. And then we're going to group the first two and the next two. So from the first two, you can pull x squared out as before. So it is x plus 2. So now the goal is to create x plus 2. It has to be x plus 2. So that means you're going to pull negative 9 out. When you put negative 9 out, you're going to get x plus 2 here. And then you write the common term first. So the common term is x plus 2. We can write that first, x plus 2. And then from the first one, you get x squared. And from the second one, you get minus 9. So since there's a minus sign here, you can actually use the difference squares to continue further. So that means we can write this one as x plus 2. You can write this one as x squared minus 3 squared. So that means there are more factors now. So we can write this one as x plus 2, x minus 3, and x plus 3. So that's the complete factorization for this. This is what we call the grouping method. So you can try these problems as exercise. So let's say we have x3 plus x squared minus 5x minus 5. So you can try this. And also, like for example, like if we have a trinomial, and we can actually use this method even in that case. So for example, if you have something like that, remember we talked about how to solve a problem like that earlier using the magic factorization, but you can use the grouping method for this one. So what we're trying to do, as before, we can look at the product here. So that means negative 6. So again, as before, we can think of the two numbers that's going to give you the middle term. So you can see that the two numbers that's going to give the middle term is 6 and negative 1. So what we're going to do, we're going to rewrite the middle term using those two numbers. We can use these two numbers to write the middle term. So that means you can write the middle term as x squared plus 6x minus 1x. It's an exaggeration, like minus x minus 3. So that's what we do. So we rewrite, and because you can see this is simply a 5x. That's the middle term. Now we can see there are 4 terms, so we can use the grouping as before. So we're going to group these two and those two. So from the first set, you can see you can pull 2x out. If you pull 2x out, it's going to be x plus 3. Now the goal is to create the x plus 3 term. So that means you can pull negative 1 out. If you pull negative 1 out, it's going to be x plus 3, or negative out, just negative sign. And then you can see we write the common factor, which is x plus 3, and then we write the other two terms next. So that means 2x minus 1. So this is how we use the grouping method to factor trinomials. So you can try this one as practice. So let's say 2x squared plus 5x minus 12. So you can try this as a practice problem.